I just love this cartoon. It's true that astronomy does have a lot of math to it, but this is not a mathematical course. We teach conceptual astronomy here, so it's going to be more about the concepts and less about the numbers. The most common question I'm asked is, why do I have to take a science? I'm not a science major. I'm an art major or journalism major. Why would I have to take a science? Well, science is for everyone, not just the science majors. Most people don't even really have an understanding of what a science is. If you think about what a science is, well, then it might make more sense why you have to take one. Most people think of science as biology or chemistry, maybe physics, and all of these things have one thing in common: the way they go about answering a question. Because a science isn't an object, it's not a table or a rock or a thing. It's actually a process. It's the process by which you go about trying to answer a question or solve a problem. And it really doesn't matter what the question or problem is, it's how you go about trying to answer it. All of these topics, biology, chemistry, physics, astronomy, try to answer questions in the same way, using what's called the scientific method. Now, knowing how to find the answer to a question is really a very important tool. It's something everyone should be able to do. We've all met people who couldn't answer a question or solve a problem to save their life. And unfortunately, sometimes they happen to be in positions of authority above you. You've met some of these people. I know you have. And you wonder how they got there. Well, hard to say. But everybody should have a science. Everybody should take a science because it does help you learn how to find answers to questions, and that is something that everyone should be able to do. It'll help you in your life. It'll help you in your career. Why else should you take a science? Well, because you can learn about these topics like biology or chemistry or physics or astronomy, and it will allow you to learn about the world around you. Unfortunately, we've all met people who say very odd things like the sun and the moon are the same object. They just look different day and night. That is absolutely incorrect, and I heard someone say that not too long ago at an elementary school. Nobody wants to say things like that, so it is really good to learn a little bit about the world around you, or the universe, or the planets, so that you can have a good, informed conversation with the people around you. Now, answering the question. To answer a question or solve a problem scientifically, you have to use the scientific method. There are many ways of showing the scientific method. This is one that I like, but you'll see many different drawings. When using the scientific method, you start with a question, and it can be any question in any topic. You could choose, why is the sky blue? Or, can I go out drinking with my friends on Sunday night? Once you have your question, you need to explore what you know about it and what you need to know about it in order to make a good answer. If you choose, can I go out with my friends drinking on Sunday night, it would be easy to give a knee-jerk response of yes or no, but that's not a scientific way of answering. For this example, you might need to know how much money you have available, where you're going, if you're old enough, if you have transportation, if you have child care, do you need to be at work that night or the following morning, or anything else that applies to your life. If you look carefully at these things, you'll notice that there are two types of information here: rules and assumptions. Rules can't be changed. For example, no matter how often I beg the teller, she never adds extra zeros to my account balance. Assumptions are just that. You might assume that a friend of yours would be a designated driver. You might assume that a friend would be child care. But be very careful of assumptions and use as few as possible. Once you have your rules and assumptions, you make your first untested model answer to your question. It's really just an educated guess. We call it a hypothesis. Then you make predictions based on your hypothesis. That's an important step, for you will later compare your data to your predictions to help you determine if you were successful in answering the question. Once predictions are made, you run the experiment and take data. Was your answer correct? If not, evaluate what went wrong. Usually it's an incorrect assumption, although it could be a complete misunderstanding of the problem. Change whichever portion is incorrect, and then try again. Keep doing this until you have a hypothesis that works. When you have a hypothesis that has been tested many times in many ways and it continues to work, it becomes a theory. Now, in everyday life, the word theory can mean a random guess. However, in science, it's something that is well tested. For example, the theory of relativity. In the past, if a theory was well tested and shown to be valid, it would become a law. That is, Newton's law of motion or his universal law of gravitation. We don't give out the title of law anymore. It takes only one experiment or piece of data to disprove an answer and force scientists to start over. Newton's law of universal gravitation does not hold true near massive stars. Still, we don't take the title of law away from his work. You can see how he wouldn't have been able to test that, being stuck here on Earth where we no longer are. And we don't take away the title because, well, he's dead. It would be rude. However, we don't give out the title of law anymore. The best title today is that of theory, Einstein's theory of relativity. You will note that nothing in science is ever really proven, ever. We're just waiting for the one bit of data, and data can be thought of as a measurement or results, any of those words work. One bit of data where it shows something in the model is wrong. And then we have to, well, reevaluate, change the assumptions, change whatever went wrong, and start again. Sometimes that's a minor revision, and in other cases you have to throw the whole thing out and start over. So nothing in science is ever truly proven. Don't believe it when you hear it on TV. Science has proven this. Science doesn't do that. Science must also be repeatable. Good science can't be unique. If you drop an apple and it falls up, but you're the only person that's ever happened for, and it only happens once, you're going to have a hard time doing any science with it. Good science is repeatable. There's a reason we have people write lab reports. A good lab report states what you did, what you got, your data, what it means, in a way that somebody else at the same educational level could pick up that lab report, read it, and repeat it and get the same answers. So as long as you follow this scientific method, as described, you are doing science, regardless of the topic. Remember that good science is only good if it describes the data and the data actually matches the predictions. Remember that you can never prove anything, and you may disprove a hypothesis or theory if you have any data that doesn't go along with either the predictions or the model in question. And then you have to revise or even scrap the existing theories. A particular scientific theory may not be unique, it must be repeatable, or it is not good science. A pseudoscience is something that doesn't follow scientific method. Pseudo means false, and therefore pseudoscience is a false science. A pseudoscience is identified not by the subject matter, but by how it treats its data. Good examples of a pseudoscience are astrology, religion, ufology, and phrenology, which is the belief that a bump on your skull can tell you your personality. Being a pseudoscience does not make a topic bad. It doesn't make it illegally immoral or fattening. It just means it's not a science. They don't follow scientific method. Art is a pseudoscience. When was the last time you painted a picture using scientific method? It doesn't use it. Astrology has very respectable origins in ancient cosmology. It was originally a religion. We still look at it today, sometimes for entertainment purposes only. You'll note on the screen a chart, an astrological chart. And you can make this, you can look at this in terms of the scientific method. There are rules. You were born at a certain time. The planets, the stars, the sun, the moon were in certain places at the time of your birth. And then there are assumptions that these things mean certain things for your life. Now, looking at this, you make a model. This is a model on your screen for a person born at a random time and place. And from this, they make predictions like a horoscope. For this person, maybe the horoscope was, you're going to have a wonderful day, you're going to meet the person of your dreams, you're going to fall in love and win the lottery. And then the experiment runs. This person has a day, and there is data from this. They might have a wonderful day and meet the person of their dreams. Who knows? They might even win the lottery. Lucky them. However, have you ever had a horoscope that did not match your day? Have you checked? Okay, so if you have data that does not match the prediction, well, if you're doing science, you then need to change the model. Figure out the problem, change it, try again, and keep trying until you get it right. Does anybody ever call you and check to see if your horoscope matched your day? Ever get called by the horoscope hotline to check it out? Probably not. If you did, well then this might become a science, but because nobody takes the data and uses it to adjust the model accordingly, this is still a pseudoscience. This is an example of a pseudoscience, and one I wish I could use more often.